Hello dear students. In the previous class we were discussing about the fundamentals of surface chemistry. What is adsorption, what is desorption, adsorbent, absorbate, all those things. And today we are going to discuss about a few more topics from surface chemistry. The very important term from surface chemistry is isotherms. What is isotherm, if you ask? Iso means it has got a meaning constant, therm means temperature. So the hint towards the concept is at constant temperature. So let's look into what is this adsorption actually. Adsorption actually basically an equilibrium process. What type of equilibrium process, if you ask? So if you imagine a container, consider an adsorbent and a gaseous adsorbate in a closed vessel. So let's imagine a closed vessel. Inside the closed vessel, an adsorbent is there. Adsorbent is the substance on which the adsorption happens, and a gaseous adsorbate. So let's take this full because I will be showing the small bubbles as the gaseous adsorbate. So what happens? There are small gaseous molecules. What will happen once the adsorption starts? These gaseous molecules are going to get adsorbed on the surface of adsorbent, and here, being it is a closed container, it will have a pressure. So what happens as the adsorption increases? Many gaseous molecule will be getting adsorbed on the adsorbent. So what happened to the pressure? Pressure will be keep on decreasing. So initially the pressure was constant, so adsorption happens. And what is that equilibrium process means? Once the adsorption starts, there you can expect desorption too. The molecule will be getting away from the adsorbent. That is what we call desorption. So adsorption happens, desorption happens, and there will be an equilibrium. At some particular point, the substance of gaseous molecule which is getting adsorbed on the surface of the adsorbent and the gaseous molecule which is not adsorbed, which is desorbed, both will be constant. That's how we call it as equilibrium. So these two processes are happening: adsorption, desorption. Adsorption is on the surface, desorption is away from the surface. So it is observed that due to adsorption, the pressure of the gas decreases initially, and it will be decreasing and becomes constant after some time. This indicates that the state of equilibrium has been attained. So please understand, adsorption is basically an equilibrium process. In any equilibrium process, there will be a forward reaction and there will be a backward reaction. Here the forward reaction is adsorption and the backward reaction is desorption. And we have considered a closed container which contain an adsorbent and adsorbate gaseous molecule. So gaseous molecule will be getting adsorbed on adsorbent. So what will happen? The pressure will be decreasing, and pressure will be keep on decreasing and becomes constant after some time. This indicates that the state of the equilibrium is being attained. So if you measure the pressure after some time, you could see that the pressure is becoming constant. That means no adsorption is happening, otherwise the pressure would have decreased. So when the pressure is constant, you can say that there is equilibrium. There exists an equilibrium. Once the equilibrium is reached, the rate of adsorption becomes equal to the rate of desorption. That's why it is called as equilibrium. So there are two reaction, forward reaction and backward reaction, that is adsorption and desorption. Both are happening at equal rate. That's why we call equilibrium. So the extent of adsorption is expressed by X by M. That's how we express the extent of the rate of adsorption. To what extent the absorption is happening? X by M. What is X over here if you ask? X is the mass of the gas adsorbed and M is the mass of the adsorbent. The substance is getting adsorbed is called adsorbate, on which it is getting adsorbed is called adsorbent. And here both are important. The adsorbent is important and adsorbate is important. And adsorption means the adsorbent will be constant. So what you will do, you will take a particular gram of the adsorbent on which what amount of adsorbate is getting adsorbed. So the amount of adsorbate is what we call X. The amount of adsorbent is taken as M. M is the mass of the adsorbent. So come to the point, we are talking about isotherm. So we were discussing about what happened to the pressure during the adsorption process. So we have measured the variation of the pressure with respect to the adsorption at constant temperature. When you measure it at constant temperature, you call it as isotherm. This is what the idea of isotherm. So the variation in the amount of gas adsorbed by the adsorbent with variation in the pressure at constant temperature can be expressed by means of a curve. So this expression, the variation of the pressure with respect to the adsorption could be represented by a graph. When you draw a graph, then only you can call it as an isotherm. This curve at constant temperature is called the adsorption isotherm. So hope you got the story. So there is the adsorption, there exists an equilibrium after some time, so there will be decrease in pressure and the pressure will become constant. If the pressure is becoming constant, that is an indication of equilibrium is attained. And this variation, if you depict by using a graph, if the process happened at constant temperature, that graph is what we call adsorption isotherm. So in adsorption, what is adsorption isotherm? If they ask, you can say at constant temperature, a graph between the amount of the gas adsorbed per gram of the adsorbent, not the point, even the absorbent has to be quantified, and the equilibrium pressure of the adsorbate is called the adsorption isotherm. And the isotherm, a lot of research has done on adsorption isotherm. It's not that easy. As you heard, initially it will be decreasing and it will become constant. And there are various things that we have to understand about isotherm. So the basic adsorption isotherm is given by Freundlich in 1909, was the first to propose a mathematical relation for adsorption isotherm. He gave an empirical relationship between the quantity of the gas adsorbed by unit mass of a solid adsorbent and pressure at a particular temperature. So when the temperature is constant, we can call what is delivered by Freundlich as an adsorption isotherm. Now let us see what is Freundlich adsorption isotherm. A curve where the mass of the gas adsorbed per gram of the mass of the adsorbent, which is plotted against pressure. What is Freundlich adsorption isotherm? If somebody asks, you can say that it is a graph or it is a curve. What is expressed by the curve if you ask? A mass of gas adsorbed per gram of the mass of adsorbent, that is X by M, which is plotted against pressure. So you could see in the graph, X by M is plotted against the pressure. So please look at the graph. This graph is important. What is the nature of the graph? The relation can be expressed as x by m is equal to kp raised to 1 by n. This is what the expression. What is x by m? We have already told is the amount of gas adsorbed by unit mass of the adsorbent. N and k, this n and k both are constant, and p is the pressure. This relationship is generally represented by in the form of a curve and is known as Freundlich adsorption isotherm. Understand, this is the expression for isotherm, and the isotherm is drawn like this. Okay, and bit elaborate. If we speak about this isotherm, the graph comes like this. So here, in this adsorption isotherm, x by m reaches its maximum value at a point Ps. So as we have discussed initially, once the rate of adsorption is equal to the rate of desorption, the system will be attaining equilibrium. Once the equilibrium is attained, the pressure will become constant. So pressure has become constant. You see, the pressure has become constant. It will not be changing. And why it is not changing? There exists an equilibrium between the desorption and adsorption. So let's analyze it. What are the interpretations of this equation? From the curve, even if the pressure is increased beyond Ps, the extent of adsorption remains the same. This pressure is called saturation. This state is called saturation state, and Ps is called saturation pressure. So once the pressure is not going to change, the equilibrium has attained, the extent of adsorption is equal to the extent of desorption, and no change in pressure, that pressure is saturated. That pressure, the system has saturated because of adsorption and desorption, so the pressure will become saturated pressure. At low pressure, this is what the low pressure region. At low pressure, x by m is directly proportional to p. You could see that the pressure is increasing. Pressure is increasing directly proportional to pressure. So when the pressure is directly, you can have, so x by m is directly proportional to p. So you can introduce a constant, that is k, then you can write x by m is equal to k into p. So it's like a straight line, keep on increasing. At low pressure, it is like that. And at very high pressure, x by m is independent of the value of p. So what happens is, x by m is equal to a constant. Means x by m is independent of pressure. X by m doesn't know about pressure at high pressure. This is expressed as x by m is equal to p naught. P naught means it's a constant. In the intermediate range, it's not straight, it's like a small curve. In the intermediate range of the pressure, x by m depends on p raised to 1 by n. P raised to 1 by n. So you could see that p raised to 1 by n, where n is the positive integer. So you can interpret the same equation in one more way. If we take that's how the ultimate. If we take the logarithm of the above equation Vx, we get log x by m is equal to log k plus 1 by n log p. So this equation resembles some other equation. What does that equation ask? It is y is equal to mx plus c. When you get an equation y is equal to mx plus c, you can always plot a graph where y is taken against x and m is the slope and c is the intercept. So here log k is supposed to be the intercept and 1 by n is supposed to be the slope, and log x by m will be in one axis and log p will be in another axis. So we get a straight line. It's proved over here. So we have taken log x by m along y axis, log p along x axis, and you got a slope, you got a straight line with a positive slope, and the slope is 1 by n, and the intercept is log k. The value of 1 by n in Freundlich adsorption isotherm ranges to 0 to 1 minus 1, 0 to 1. Please understand, 1 by n value will be 0 to 1. When 1 by n is equal to 0, when 1 by n is equal to 0, x will become constant, because when 1 by n is equal to 0, y does not have any significance. So the adsorption is independent of pressure. And you have to understand one of the demerit of Freundlich adsorption isotherm, that it could not explain what happens to the adsorption when the pressure is very high. This is what the demerit of Freundlich adsorption isotherm. Thank you. And next class we need to learn about next adsorption isotherm, that is Longmire adsorption isotherm. For the time being, goodbye. And you will have a test once this chapter is over. You will have one more session. I don't think it is required to complete the chapter. We'll have an assignment soon.